right? It's going to use all of these equations, and then you cross out what you're trying to find, and then you solve for the temperature change. Now, the other way you can go is the summation equation. I prefer to use the summation equation. We'll do both, and then I'll show you why I prefer the summation equation. This is the target reaction that we're trying to find for delta H. Adam. Heather, this is the target reaction we're trying to find for delta H. Now, what do we know about elements?
You say it backwards. Because it says delta H for the target. You said target for the target.
This is the target reaction we're trying to find delta H.
Delta H and then
That's RXN. Sorry. Okay, so the point here, what is the heat of formation for the elements? You remember from yesterday on the video? The girl told us the heat of formation for all elements is...
The girl I definitely didn't listen to.
Yeah, she talked way too out there.
It's 0. Okay, so the heat of formation, delta H for elements is 0. So we have two delta H's here that are both 0. So you can really almost forget about them, and that's why you see that this can be found right here and that this can be found right here. Does everybody see that? So your elements, you just kind of forget about them. Not a big deal. All right, so now let's take a look at this from the Hess's law. This is going to be 3 halves. This is going to be 2 AL. So we're not really concerned about these over here. This is all that we're concerned about. So we have to divide this by 2. This iron oxide, maybe 6, iron 3 oxide. Iron 3 oxide is found right here, right? So we have to flip this because we need to get it on the reactant side. So when we put it over here, we have to change the sign from delta H negative to positive. Now the second problem is that in this balanced equation there's a 1 there. And we have 2 there, so we have to divide these by 2. That ends up being that, and then we have to divide this by 2. Values from these equations to get the target are right here. Does everybody see that? And all we basically want to do now is just add them together, right? Now, when we flip these, we should have been able to cross out some of the aluminum. That's a problem there. It doesn't seem like it's doing that from what they were showing in the book yesterday. Our oxygens do. Does everybody see that? Oh yeah, we don't have to worry about the aluminums because their delta H is 0. Yeah, so those are 0 there. Well, that's what she talked about in the... No, it has no effect on them. That's why they want to mess with you a little bit. They're putting that there to trick you a little bit. But the delta H of formation for elements is 0, so it doesn't really matter that they cross out because it's going to be 0. Okay, so does everybody see this method is a little bit confusing? That's why I prefer this one. This one's a lot easier to kind of deal with. The summation, yeah, it's a shortcut. So we end up having negative 850.8. So that's our answer here, right? So we're going to use this other method and see if we get the same answer. It's just kind of a double check that occurs in this one. This is what makes this one a lot easier to use. So I would use this one first, no flipping of the signs. All you have to do is look at the values, make sure that you have the right molar value. Like if you have, let's say, 1 in your standard equation and you're looking up one that has 2, then you're going to need to divide it in half so that your reaction is correct for the delta H. So you can see that in the book right here where they have the negative 75 kilojoules for methane. Now on the internet they're close to that. They don't have the same value. Which one's probably correct? I would say probably the one in the book. They're saying negative 67 for the delta H of the methane CH4. So heat of formation for methane. The point is that it's negative. That's really the point that I'm trying to draw your attention to. And you can see here in the book, when they do the summations, they have the negative there. They didn't change the sign. So this, once again, is the easier one to do, the summation one. Recommend that one. So once again, both values are the same. Both methods can be used to get the answer you desire.
Whenever you're in your home, and you know that gases tend to spread throughout Earth's atmosphere, why do gases
to be more disordered, causing the system to have greater entropy than when the particles are closer together.
Standard enthalpies of formation are stated based on the following assumption. Elements in their standard state have a triangle H degree F of 0.0 kilojoules with
The moment you activate it, similarly unprotected iron objects rust whether
Keep going.
rust whether you want them to or not. Rusting is spontaneous. Any physical or chemical change that once begun occurs with no outside intervention on spontaneous
Things are moving towards disorder. That
Oh, you're talking like in a
once you're born,
sense or like
once you're born, you're progressing towards death. So that would be disorder is when you die, because you're gonna break apart. But
not true?
well, most people don't want an older car, they want a newer car, right? They want a newer house. And
They have
those,
longer time until it disorders.
so you're associating yourself with things that are ordered. So if we are more comfortable with things that are ordered, Hope,
Shut up, Hope, for like 5 seconds, please.
if we are more comfortable, Hope, with things that are ordered, why is that?
Because order is predictable.
No, human beings, most animals in general, desire to reproduce. So that desire to reproduce is going in the direction of order. When you're trying to make something, you're trying to move in the direction of order. Now, there are people who are old, like Trump. I mean, he had a kid not too long ago, but yeah.
Oh wait, how old is
Um,
What's the youngest one? Baron, right?
Yeah, I think so.
Also, what a douchey name for your son. Baron. It's like asking him to be like
Yeah, kilojoules. So you can use either method, that's the point. You can use the Hess method or the heat of summation method. I prefer this method because you don't have to change the sign and it just goes a lot faster. Here you've got more potential for having a mistake.
The procedure can be summed up in the following formula. Let me just read it. You can see how this formula applies to the reaction between hydrogen sulfide and
Some energy from the surroundings must be supplied to get the process started. For example, you might use a match to light a Bunsen burner in your school lab. Suppose you reverse the direction of the equation for the rusting of iron. Recall that when you change the direction of a reaction, the sign of triangle H changes.
Process, Brendan.
No.
Yes, Kayla just read that it is.
Kayla, my name is Kaya.
Kaya, sorry. Kaya just read that it is a spontaneous process.
Possible ways that the energy of a system can be distributed, and this is related to the freedom of the system's particles to move in a number of ways that they can be arranged.
Such a way which states that spontaneous process always proceed in such a way that the entropy of the universe increases. Entropy is sometimes considered to be a measure of the disorder or randomness of the particles that make up the system. Particles that are more spread out are said to be more disordered, causing the system to have a greater entropy than when the particles are close together.
Now, are you going towards disorder or towards order? Is life moving towards order or disorder? Raise your hand if you think disorder. Explain. Yeah.
I think it's disorder because a lot of people don't like being controlled.
Okay. When you're trying to, let's say, reproduce, you're moving towards order. When a baby is born, you've got the most, I guess you'd say, change in the DNA to, I guess, designate that child as different from you. And that creates, new life. Life is considered order, more order than non-living. That's how we determine the difference between the two. Living things tend to have DNA and they reproduce, and that reproduction is a sign of order. Is everybody clear? This is part of the reason why you want a new home and a new car, because you're driven in that direction of reproducing. You may not think you are, but your hormones are. Your hormones will drive you to want to reproduce. Has anybody experienced that, Regine?
Let me see the shoe. Let me see. Just because they have the same
Yeah. Kilojoules. These are in kilojoules.
I thought you said I couldn't video you.
It's Hess's law, and they give you 2 CO2 plus H2O yields C2H2 plus 5 halves O2. Now, you learned when you balanced equations you cannot have 5 halves. So what I did was multiply it times 2 to get rid of the 5 halves. This ends up making 5, because 5 times 2 is 10, divided by 2 is 5. Does everybody see that? Yes. That's step 1. Now, what I want to do now is get it to where these reactions match up to this reaction. So you see right here we have a C2H2. We need to have it over here in the product, like it's a product here, a product here. So I have to flip the equation that's given in this example. It has the C2H2 as a reactant. So when I do that, it changes the value for delta H to a positive value. Then I'm going to multiply it times 2 because I have 2 of them here. And I have to multiply this times 2. Now I'm going to, with the H2O, I'm going to invert that because I want the waters to cross out here to where I have waters there. So when I flip that, I'm going to multiply it times 4. So I have 4H2, and then I have 2O2, and then 4H2O. Because the original value for O2 there was 1/2. See, it says H2O yields H2 plus half O2. So if you take 4 times half O2, you get 2. That's why you see a 2 there. And then you have 4 H2O. It balances out. When you look at the oxygens here, you have 4. And then you have to multiply this times 4. That's the value. It's negative because we had to flip it. In the problem it's 71.2, but it's negative now because we flipped it. Also, we have to flip this one. The value is CO2 and H2O in the product, so we got to get it in the reactant, and then it yields the C2H6 plus 7H2O. And that's coming from when I multiply it times 2, because given here it is 7 halves O2. And 2 times 7 halves is 7. So, you'll notice here that the 7O2 is going to cancel out here. 2 taken away from 7 is 5. See that? We got 4 H2Os here and 6 H2Os there. That gives me 2 H2Os. So those things cross out. Then you got to multiply this times 94, gives you 189. This times that gives you 284.8. And then 2 times 283 gives you 566. You end up adding all this up, and the answer ends up being 235 because you got to divide it by 2, giving you your original equation. 235 is the answer.
Process
process. Some energy from the surroundings must be supplied to get the process started. For example, you must use a match to light a Bunsen burner in your school lab. Suppose you reverse the direction of the equation for the rusting of the iron. Recall